All right, so the easy part would be the limit and the sigma, because the reason why that's easy is because it's always there, right? There's no mystery about that. So it's going to be limit as n heads towards infinity of sigma from I equals 1 to n. So we should all have that. That's going to be common for all of these. Then the next piece is the base length of all the rectangles. What we need to do to look at that is we need to notice the 3 and the 8 define our domain. And the difference between 3 and 8 is 5. And so if we have a full width of 5 and we want to squeeze n rectangles in there, then each base length is going to be 5 over n wide. So that's our base of the rectangle. And then finally we have the height of each rectangle. Of course, the height is determined by the y value of the curve, and the y value of the curve is given to us as part of our integrand. It is, of course, right here, and it is input to the fourth minus 1. And then the final step is always the toughest step, or maybe I think you guys are getting really good at this, so maybe it's not very difficult for you anymore. We want to put in our input. What is the lowest possible input? 3 is right. And then we're going to just progress across the region. And every time we move from one rectangle to the next, how far do we have to jump on our input? That's right, the width of a rectangle. So plus 5 over n. And then we always want to multiply that by I so that we can progress from the first to the second to the third, dot, 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 all those inputs. At that point, this is our expression for height, and we've got it. Question, Bailey.
So if they give you a certain number of rectangles, do you just plug that in for n and then solve?
Sure. Yeah, so if they were going to ask that, they wouldn't ask this question in the way that it's worded, because when it says set up a Riemann sum expression that is equivalent to that, that means we're finding the exact area. So if they said, if it was one of those questions we've had in the past where it was like, use 10 rectangles to approximate blah, 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 we could use notation like this. Although I got to say, if we're only going to be doing like 3 or 4 rectangles, it's probably easier just to go base times height, base times height, base times height, instead of writing out a full Riemann sum. But that is what the n stands for. If we wanted to use 9 rectangles, we'd get rid of the whole limit as n heads towards infinity thing, and we would say n is 9.
Okay, so it would just be 5 over 9 times.
3 plus 5 over 9, I to the fourth minus 1.
What do you do about the I?
Well, so then the I would start at 1. So like if you, this is great because this really gets at the heart of what this is. So if it said use, I'll say 5 rectangles, that means wherever you see an n, you'd put a 5. And so it would be sigma from I equals 1 to 5 of 5 over 5 times 3 plus 5 over 5i to the fourth minus 1. And then, remember this sigma, all it means is add up a bunch of stuff. So you'd start off and you'd make I 1. And so we'd say, all right, if I is 1, this equals, well, 5/5 is 1, and it would be 3 plus 5/5 times 1. Well, that would just be 3 plus 1. That's 4 to the fourth, 256, minus 1, 255. And then you'd say plus, now let's plug in a 2 for I. You'd get out a similar looking expression, and then you'd plug in a 3 for I. You'd stop when you get to 5.
Okay, so if they asked us that, because there's one on WebAssign that is like 8 rectangles, so we would just do that for...
I equals 1, 2, 3, 4, 5, 6, 7, 8. I don't know the exact question you're referencing, but if it is exactly what we're talking about, then yeah.
Okay. It was just limit process.
Well, is there a limit as n goes towards infinity on the front of it? Because that would make a big difference.
For mine, it was just 27 minus x cubed, and it's 1 to 3 interval with 8 rectangles.
Okay, yeah.
So would that be a limit to infinity?
That would, no, 8 rectangles means 8 rectangles. Limit as n goes towards infinity would be n heading towards an unbounded number of rectangles.
Oh, so we limit in to 8?
No, like if you are told to use 8 rectangles, this is out.
Okay.
Right? But if you are,
It just goes for n on the top of the sigma.
yeah, but if you're told, hey, let's find the exact area, then you got to have that limit as n goes towards infinity, because that's the only way to get the exact area.
So that's using like the right limit, like the right.
Yeah, we talked about this the other day. Yeah, you'd set it up. You could have I equals 0 if you wanted a left sum. Yeah. And so like I mentioned to her, like for our purposes, like for the sheer amount of data, for us, like a relatively small amount of data, I don't, like if you were going to use like 5 rectangles or 3 or 4 or whatever, I don't think using sigma notation would be as efficient as just going like base times height, base times height, base times height, add them up. I think that would be far more efficient if you're going to do a left sum or a right sum. I don't think I would do this with either one of those.
So like on the website, just add them up.
Yeah, I would just like figure out what the bases and the heights are, multiply them and add them up. To me, that seems easier. If for whatever reason you think the sigma notation and the formulas that go with that are easier, then that's fine too. Yeah. Anybody else with a question? Okay, so then I wanted to kind of sum up this whole Riemann sum thing here with number 3. I would say that number 3, or some question like it, is by far the most likely sort of question you would see on an AP test, or one of my tests for that matter as well. Something like number 3. So which of the following is equivalent to that Riemann sum? You've got 4 definite integrals there for you to choose from, and we're going to try to figure out which of those 3 matches. So take a minute, see if you can figure it out. Feel free to discuss with a table partner and figure out what you think, A, B, C, or D. Ready to go. The process of elimination is always a viable strategy on a multiple choice. Clearly, you guys all eliminated B and D. Why did you eliminate B and D?
The input has a negative 2 first.
So the input starts at -2, and then how does that contrast with B and D?
That one has 0.
Starts at 0. Great, that's awesome. That's exactly what I think you should have seen. So you see that one starts at 0, that one starts at 0, yet our Riemann sum starts at -2. That right there is a good enough reason to eliminate B and D. That's awesome. You guys noticed that really, really well. Okay, so then that leaves us with A and C, and you guys all chose C. So the only difference between A and C is that A has that negative on the x cubed. Why did that not work with the Riemann sum, in your opinion?
Negative 2 doesn't have a negative.
So let me rephrase my question a little bit. If A was going to be the correct answer, how would the Riemann sum need to look different? Yep, okay. So we'd have to squeeze it in, but we'd need a negative sign right here, wouldn't we? That makes sense? You see my little blue minus sign in there? Yeah, you'd have to have a little tiny minus sign right there. That would actually make A the answer, right? But it wasn't there. So the fact that you all got C is a really good thing. Awesome. You guys are doing great. Like I've done this. You guys know I've done this for a long time. And I've done this Riemann sum thing for a long time. And I've seen other groups struggle, I don't know, twice as hard as you guys have struggled with this Riemann sum thing. So that's an encouragement to me. So I hope that's an encouragement to you too. It's really, really good. All right, so tomorrow we'll start talking about areas, and we'll start kind of rounding this out a little bit further. But for now, we're going to do some quiz reviewing. So that means that the quiz from the one that you just took,
Looking at it.
we're going to review it.
Oh, did you grade it already?
Oh, well, I haven't graded yours.
Oh,
Sorry, I had a class last period.
that's okay.
But everybody else's that has taken our graded. So that means Nick needs to go, and that's it, huh?
Wait, do I have to
Mine.
go? Oh, no, I took
You
it.
took it.
Yeah,
So you just won't be able to get the same direct amount of feedback, but you just took it, so you probably remember some of the things you saw, and so it'll still be helpful. Yeah. Okay. And I think Nick will I've at least budgeted the rest of the time just so that everybody has enough time to ask questions. So you can. Well, Nick.
Did you get a lot of decimals?
All right. Oh, see if I can figure out where you guys are. There you are. All right, Stu. This is a different class. Different class, different class, different class, different class. This class, okay. Heather. There you go. Renee. There you go. Oops, sorry. Anna is not here, but Ayana is. There you go. Bailey, there you go. There you go, Andy. There you go. That's it. Sorry, Marguerite. I had class last period.
It's okay.
I normally would try to turn that around real quick. Hey. So I'll give you all a chance to look those over here just for a minute, and then I'll be happy to answer whatever questions you might have.